Hello, everyone. Welcome back. We are on our seventh part of chapter 16. And this is going to be a kind of four-part continuation where we are trying to figure out how to find the pH of salt solutions. And this is kind of what I've been working us towards through the videos that I've made up until this point. And so in this video, I'm going to talk about species containing ions that behave as neutral ions, meaning that they are neither acidic nor basic in solution. Okay, so to teach this, I am just going to show examples. And this is because I believe that as I work through these examples, you'll be able to see how I go about doing this and kind of the ideas behind it. So, example 1, do you expect a solution of KBr, potassium bromide, to be acidic, basic, or neutral? And so the first thing that we have to do is we have to dissolve the salt in water. And so I'm dissolving salt in water. And so notice that to represent this in the equation, I start with the potassium bromide solid. I put it in solution. That's what this H2O over the arrow means. And because this is an ionic species, remember, it has a cation combined with an anion or a metal with a nonmetal. Because it is ionic, when in solution, it breaks up into its individual ions. Notice that the charge of these ions match the charge of the species in its solid form, as this is K plus and Br minus in this molecular formula. Okay, so now that I know what ions are formed in solution, the next step is I need to investigate the reaction of the cation with water. So I'm going to look at the reaction of the cation with water. So now remember that cations are acids in disguise. And so this acid cannot take a proton. Instead, what's going to happen, because this is a strange acid, and we're going to see why here in a minute, that remember that this water is HOH. Otherwise, note that it's dissociating into H plus and OH minus. Because this K plus is ionic, this K plus is going to combine with that OH minus. I'm going to just write this as KOH to simplify this. And we also get H3O plus left over. I'm going to remove this. Now, we need to think about, does this cation have a Ka? Well, I drew this with a single arrow, which means that there really isn't, the Ka is not applicable. There isn't a Ka for this reaction because there's no equilibrium. And there is no equilibrium because of this KOH. So this potassium hydroxide, this is one of our strong bases. Again, if you don't remember your strong bases, be sure to look back at video 1 so that you know these. You need to have these memorized. So KOH is a strong base, which means that K plus is the conjugate acid of a strong base. The conjugate of a strong is neutral. And this is because as soon as this KOH forms, it immediately dissociates back into its ions. And so in solution, there is no such thing as KOH in solution. It's really OH minus and K plus, which is exactly the reactants of this reaction. And so what we do is we write this reaction as K plus aqueous plus H2O liquid is no reaction, because no KOH forms. The Ka for this reaction is not applicable because there's not a reaction. And so the K plus in solution is neutral. It results in a neutral solution. Okay, so now that we talked through that, we have to do the same thing with the anion. So we need to look at the reaction of the anion with water. Okay, and so the anion in this case is Br minus plus water, liquid, goes to form HBr plus OH minus. Now, we know that HBr is a strong acid. Again, if you haven't figured these out, if you haven't memorized these yet, go back to video 1, get your list of strong acids, make yourself some flashcards. Let's get these figured out. So HBr is a strong acid, which means that it disassociates completely in solution. And so that means that really the reaction of Br minus plus water, liquid, is no reaction because no HBr actually forms. And the Kb of this doesn't exist because there is no equilibrium. And so that means that Br minus is neutral when in solution. So now we step 4 is put it together. We know that, let's make this prettier. I'll put it together. We know that K plus in solution is neutral. We know that Br minus in solution is neutral. So a neutral species plus a neutral species results in a neutral solution. So, what is the pH of this solution? Should be about 7. So we can say that the pH of a KBr solution is approximately 7. Okay, so in these next few slides, I'm going to flip through and I'm going to talk through the same idea again. Same example, I've just typed it out neatly for you. Okay. Oops, but I didn't change my slides. I adjusted the answers, but I didn't adjust the question. So here I've got KBR, I've got KBR, I've got K plus. You're just getting a little preview for the next slide or for the next video. So K plus mixed in with water creates KOH, which is a strong base. As soon as the KOH forms, it immediately dissociates, and so K plus H2O gives me no reaction, and my potassium ion behaves as a neutral species. And we have the same sort of thing with the bromide ion. The bromide ion plus water forms HBr, hydrobromic acid. That is a strong acid, which means that as soon as HBr forms, it immediately dissociates, giving us no reaction when bromine is dissolved in water, and so bromine behaves as a neutral ion. And let's fix this again, because copy and paste. Oh, look, I fixed it here. So when KBr dissolves in water, I get these two ions. In summary, I know that both behave neutral, and then a neutral plus a neutral gives me a neutral solution, and so I would expect the pH to be approximately equal to 7. Okay, so that's my example for a salt dissolving in water forming a neutral solution. In the next video, I'm going to talk through what happens if you have one species that is not neutral. And then in the video after that, we will talk through what happens if you have two species that are not neutral. And then after that, we will talk through what if a species is both an acid and a base. So stay tuned, keep watching. Remember, I have lots of office hours and I'm answering emails, and reach out to me if you need me.